Algebra 2 students to the homework help video, page 378, numbers 11 through 39. Let's go ahead and jump right into this, and hopefully you will, it's 11 through 39 odd. So, I don't have a keyboard here, but 11 through 39 odd. Here we go. Alright, problem number 11. The steps for solving radical equations are: step 1, isolate the radical. Looks like to me the radical is already isolated. Step 2, we're then going to eliminate the radical. Okay, so we're going to eliminate a square root. So there's a 2 here. In order to get rid of a square root, you square the whole side. But if you square one side, you must square the other side. Alright, so there we go. When you square a square root, you're left with just on what's on the inside. And 20 to the second power is 400. Well, we're done. There's nothing else to do except always check your answers. Always, okay? So we go to the original problem. We put 400 in for x right here. And the square root of 400 is 20. 20 equals 20. Checks. Alright, moving on. Alright, moving on to number 13. Alright, now, there's 2 ways to do this. I am going to work it out both ways to help you. First of all, you can rewrite the rational exponent as a radical. So y to the 1/3 is the same thing as the cubed root of y to the 1 power, or the cubed root of y. Okay? Everybody see that? Minus 7 equals 0. Now, step 1, isolate the radical. So we're going to bring the 7 over and make it a positive 7. Step 2, eliminate the radical. We have an index of 3, so we're going to raise this side to the 3rd power. However, if you raise one side to the 3rd power, you must raise the other side to the 3rd power. Okay? When you cube a cubed root, you get what's on the inside, y. And then 7 to the 3rd power is going to be 343. So there's our answer. Now the last step, of course, is to check your answer. So we're going to put 343 in for y right here. So we have 343 to the 1/3 power. If you type this into your calculator right here, you'll get 7. And 7 minus 7 is 0. So the answer is 343. Now, I showed you another way to solve these, and here it is. If you have a rational exponent, you isolate the rational exponent and its base. So bring the 7 over and make it a positive 7. And then you flip the fraction. You raise this entire side to the 3rd power because you're flipping 1/3. 1 over 3 flipped is 3 over 1. So we're raising both sides to the 3 over 1 power. Well, when you have a power raised to a power, you multiply these. 1/3 times 3 over 1 is 1. So you have y to the 1 power, or in other words, y. And then 7 to the 3rd power is 343. Now, here's the catch. You have to put plus minus in front of this number when your denominator right here is even. In this case, it was odd, so I don't have to worry about it. That's where it gets a little tricky using this method. No, I'm okay with this method. Okay, I really am. But just be careful. You always got to check and look at that denominator. Okay, we'll do a bunch more of these throughout the homework. Alright, number 15. Okay, we have a radical equation. Step 1, get the radical by itself. So we're going to bring the 2 over and make it a negative 2. So now I'm left with the 4th root of 2x equals 4. Now step 2, eliminate your radical. It's an index of 4. So I'm going to raise this side to the 4th power. If I raise one side to the 4th power, I must take the other side to the 4th power. When you take a 4th root to the 4th power, all of this cancels, leaving you with 2x. Now, 4 to the 4th power is going to be 256. So step 2 is accomplished. We eliminated our radical. Now step 3 is solve the equation. So divide both sides by 2, and we get 128 for an answer. Okay? Now, that is the right answer, okay? But remember, on a test or a quiz, always check it. Always. So right here for x, I'm going to put 128, okay? So under the radical here I have 2 times 128. Well, 2 times 128 is 256, okay? 256. Now, the fourth root of 256 is 4, so I have 4 plus 2 equals 6. And of course that checks, okay? Always check your answers. Alright, moving on to number 17. Alright, here we go. We have a radical equation. You should recognize that. So step 1, you want to isolate the radical. It looks like it's already isolated to me. Here's your radical. It's all by itself. Step 2, eliminate the radical. It is a square root. So I'm going to raise this side to the second power. So I must raise the other side to the second power, okay? When you square a square root, you're left over with the radicand. A plus 100 equals, and then of course you have to square 25, which gives you 625. Now step 3 is solve the equation. So bring 100 over and make it a negative 100, and you're left with 525 for your answer. Now, always check your answers because sometimes they're not accurate, okay, in a radical equation. So, where A is right here, I'm going to put 525, alright? Now, 525 plus 100 is 625. And when I take the square root of 625, yep, you guessed it, I get 25 equals 25. Check. Alright, moving on to number 19. Okay, now this is not a radical equation. This is like number 13, okay? It is a rational exponent equation. So I've taught you what to do. There's 2 ways. We'll do it the radical way first. We take this and we rewrite it like this. X minus 2. The bottom of the fraction is 2, so I put that here. And the top of the fraction is 3, so it's x minus 2. The entire thing to the third power. So I just rewrote the equation. Now I have a radical equation, okay? So when you have a radical equation, step 1 is to isolate the radical. Well, it's already isolated. So step 2 is eliminate the radical. So we have an index of 2. We're going to raise it to the second power. However, we must raise both sides to the second power, okay? Now, when we do that, excuse me, when we do that, and I misspoke on something, and I apologize, guys. I feel really bad. Go back to number 13 real quick. I told you you must put plus minus in front of this number, remember? When the denominator is odd, and that's wrong. It's when the numerator is odd, okay? That's my fault, and I apologize. Let me say it again. You have to put plus minus in front of this number when you're using this method here, and the numerator is odd, not the denominator, sorry. So we'll get to that in just a second, okay? But anyways, back to this problem. So I'm going to, right now I don't have to worry about that because I'm using the radical method, so we don't have to worry about that right now. Squaring a square root, so I'm left with this. Over here, negative 8 times negative 8 is 64. Got it? Now, I have a 3 I want to get rid of. It's a power of 3. So I'm going to take the what root? Cubed root. So if I take the cube root of one side, I must take the cube root of the other side, okay? Now, you do not put a plus minus because it is an odd index. If this index is 3, 5, 7, 9, we don't get out 2 answers. If this index right here is 2, 4, 6, 8, 10, 12, it's even. If it's even, then you put plus minus. But it's an odd index, so don't put plus minus. Now, the cube root of something cubed leaves you just with the base, x minus 2, and the cube root of 64 is 4. 4 times 4 times 4 is 64. Now, bring the 2 over and make it a positive 2, and you're left with 6. So we have our answer 6. Okay? But it's no solution. Well, let's see why, okay? Put a 6 in, for x right here. 6 in for x, we have 6 minus 2 is 4, so I have 4 to the 3/2 power. Go ahead and type that into your calculator, okay? 4 to the 3/2 power. You're going to get out 8, not negative 8. So it doesn't check, even though we made no mistakes on our work. And even though we did everything perfectly, it still came out to no solution. That happens sometimes with radical equations. Now, even though we know we're going to get out no solution, I want to quickly work this for you the other way. So here's the other way. Notice I have a rational exponent. So if you don't want to convert this over to a radical equation, then do this, okay? You can isolate the exponent and its base, and we did that. They're all by themselves. And then you can raise this entire side to flip this fraction, flip it, and you get 2/3. But if you raise this side to the 2/3 power, you must raise this side to the 2/3 power, okay? Now, here we go. 3/2 times 2/3 is 1, so I really have x minus 2 to the 1 power. Or really, that's just x minus 2, alright? And then over here on the right side, I can type into my calculator parentheses negative 8. Be sure and use parentheses, negative 8, and then arrow, and then parentheses again, 2 divided by 3, and you will get out 4, okay? So when you type this into your calculator, you should get out 4. Now bring your 2 over, make it positive, and you get 6. Now, when I took negative 8 to the 2/3 power, why did I not put plus minus? Alright, well, because look at your original fraction. Your original fraction right here had an odd numerator. That's what I was saying earlier. If your numerator is odd, you do not have to put plus minus in front of this number right here, okay? Most of you probably are going to recommend, I think most of you are going to like just using the radical method, where you take the rational expression, rewrite it as a radical, and then solve. But that's up to you, okay? Alright, number 21. Alright, we have another rational exponent equation. So I'm going to rewrite it as a radical. Alright, so here we go. The bottom of my fraction goes here. And then I have 3y to the 5th. 3y plus 5. All of that to the 1 power. Okay, now anything to the 1 power is just itself. So I'm not going to worry about the 1 power. Alright? And then minus 3 equals 4. So there I wrote it from a rational exponential expression to a radical expression. Now, step 1, isolate the radical. So bring the 3 over and make it a positive 3. So I'm left with the square root of 3y plus 5 equals 7. Now step 2, eliminate the radical. My index is 2. So I'm going to square this side and square the other side. When I square a square root, I'm left with the radicand. 7 times 7 over here is 49. Now bring the 5 over and make it a negative 5, and I'm left with 3y equals 44. Now divide both sides by 3, and my answer is 44 over 3. 44 over 3. Now you gotta check that, okay? So we come back up here, and right here for y, we put 44 over 3, alright? 3 times 44 over 3 is 44, so now I have 44 right here. 3 times 44 over 3 is 44. So now I have 44 plus 5. So I have 49 to the 1/2 power minus 3. Well, if you type into your calculator 49 to the 1/2 power, you get 7. 7 minus 3 definitely equals 4. 4 equals 4. Alright? Now let's go ahead and solve this using the rational exponential method. Notice your numerator is odd, so you will not have to put plus minus later in the problem. Okay, first of all, isolate this entire expression here, get it all by itself. So bring the 3 over and make it a positive 3. So now I'm left with 3y plus 5, all of that to the 1/2 power, equals 7. Alright, now let's raise this entire side to 1 power, where you take this fraction, you flip it, So raise it to the 2 over 1 power. And this side, raise it to the 2 over 1 power. Alright? Well, a power raised to a power, you multiply them 1 half times 2 is 1. So you really have this entire expression right here to the 1 power. And we really don't need that, so there we go. 7 to the second power is 49. And as you can see, you get the exact same thing you did earlier. 3y equals 44 divided by 3. Y equals 44 over 3. Okay? You did not have to put plus minus here. Because again, the original problem had an odd numerator. Alright, number 23. This is a radical equation. Radical equation. Alright? So, we first isolate the radical by bringing the 9 over and making it negative. So now I'm left with 5 on the right side. Next we eliminate the radical. So we have an index of 4. We're going to raise this to the 4th power and raise the right side also to the 4th power. Now, when you take a 4th root to the 4th power, you're left with the radicand. And 5 to the 4th power is 625. Now bring the 2 over and make it a negative 2. And your answer is 623. Alright? Now let's check that and make sure we're accurate, okay? Right here for x, I'm going to put 623. Alright? 623 plus 2 is 625 plus 9. Now the 4th root of 625, type into your calculator, you'll see it's 5. So 5 plus 9 is 14. 14 equals 14. It checks. Alright, moving on to 25. Okay, this is a radical equation. So please watch carefully how to do this. First of all, we're going to isolate the radical. Well, you know what? It's already isolated. So step 2, we're going to eliminate the radical. I have an index of 2 here, so I'm going to raise this entire side to the second power, but I must raise this entire side to the second power also. Okay? Now, when you square a square root, you get what's under you get the radicand. And on the right side over here, I have x plus 3 squared. Now, let's kind of take a little side note here. X squared plus 3 does not equal x squared plus 9. You should know that by now. We're algebra 2. X plus 3 squared means x plus 3 times x plus 3. You write the parentheses twice because you have a power of 2. Now take your x and multiply it through. X times x. X times 3. Now take your 3 and multiply it through. 3 times x. 3 times 3. So you get x squared plus 6x plus 9. 3x plus 3x is 6x. So now I have, instead of this, I have x squared plus 6x plus 9. Now, did you isolate the radical? Yes. Did you eliminate the radical? Yes. So step 3 is to solve the equation you're left with. So it looks like we have a quadratic equation. In fact, we do. But as soon as you bring this x squared over to combine with this x squared, look what happens. They cancel out, don't they? That's good. So we're left with a linear equation. 5 equals 6x plus 9. So now we got to bring the 9 over and make it a negative 9. So we're left with negative 4. And now divide both sides by 6 and we'll get negative 4. 6 equals x. Reduce that and we get negative 2/3. Alright, negative 2/3 is the answer. Now, let's check that like we're supposed to on a test or a quiz, okay? For x right here, I'm going to put negative 2/3. So I have negative 2/3 squared, okay, right here, plus 5, equals, here's an x, negative 2/3, plus 3. Now let's simplify the right side really quick, that's easy. 3 minus 2/3 is going to give you 2 1/3, or 7 over 3, same thing. If you're not good with fractions, use your calculator. Now, over here we're going to square 2/3. positive. 2 times 2 is 4. 3 times 3 is 9. Alright? So I have 4 9s plus 5. Alright? Now, using your calculator, take 4 9s plus 5. You'll get out a decimal. Then hit math, enter, enter. Okay? Math, enter, enter. And you should get this. You should get 49 over 9. Alright? So 4 9s plus 5. Enter, then math, enter, enter. You get 49 over 9. And the square root of 49 is 7. And the square root of 9 is 3. So the square root of 49 over 9 is 7/3. So it checks perfectly. Alright, number 27. Okay, it's not too bad here. I mean, we have two radicals, but they're both isolated. This one's isolated, this one's isolated. So they're both square roots. So we're going to raise this side to the second power. That'll take care of that radical, and raise this side to the second power. When you raise a square root to a second power, you're left with the radicand. When you square a square root, you're left with the radicand. That's pretty easy, guys. Look at that. Let's just solve for x now. Bring your x over and make it a negative x. Bring your negative 1 over and make it a positive 1. And you're left with 4 equals 1x, or just 4 equals x. So there's your answer 4. Alright. Now, let's check it and make sure we're right. Put a 4 right here. So we have 4 plus 3. Put a 4 right here. Alright. So 4 plus 3 is 7. We have the square root of 7 equals. We have a 4 right here. 2 times 4 is 8. Minus 1 is 7. So square root of 7 equals square root of 7. Alright. And that is totally correct. Moving on to number 29. Number 29. Alright. Now, this is a radical equation, okay? One of the first things I notice is I have two radicals, so you want to move one to one side and one to the other side. Alright, so... And the reason I want to do that, students, I'm going to bring the negative radical over this one, so that it becomes positive over here. Okay, that's one whole term. You move the entire thing. So you bring it over and it becomes 3 square root of y. Now, you say, well, Mr. Arrow, which radical do I eliminate? Well, that's really up to you, okay? I'm going to eliminate this one. So there's a square root here. So I'm going to take this side to the second power. But there's a square root. There's this 2 here too. I'm going to raise this entire side to the second power also. Now, the reason I did that is to eliminate this radical. Now I'm going to get kind of lucky, okay? Because while I'm eliminating this radical, I'm going to eliminate this one too, kind of on accident. Okay, but that's okay though. But that's what's going to happen. So when you square a square root, you're left with the radicand. I'll be careful over here. You're not just squaring a square root, you're squaring a 3 also. And notice the 3 is multiplying times this. So when you square the 3, you get 9. Bring down your multiplication. When you square a square root, you're left with the radicand, which is y. So we have 9 times y, which is 9y. And now we're pretty well set, okay? Let's just solve the equation. Bring the 3y over, make it a negative 3y. So we're left with negative 5 equals 6y. Now divide both sides by 6. And our answer is negative 5 6 equals y. Now, I don't have an answer up here. Let me look in the book real quick and see if I can locate that anywhere. It's saying no solution, so let's check this and see if we get no solution, okay? Negative 5 6 is the answer. I'll put it right here. Alright, here we go. Negative 5 6, so we have 3 times negative 5 6 minus 5 minus 3 negative 5 6. Well, students, can you not see right now why it's no solution? We're done. We're finished. Look right here. You're taking the square root of what type of a number? Negative number. It can't be done. So there's no way this whole side over here is going to equal 0. It's impossible. It's undefined. You can do nothing to this right here. Now let's see what this would be. This would also, this would also give you a negative number. You would get negative 5 over 2, negative 5. So when you combine them, that'd be a negative 7.5 minus 3 square root of negative 5, 6. So look, you can't take the square root of a negative number. You can't take the square root of a negative number. So, sorry guys, I had to pause the video, but I think I was saying you can't take the square root of a negative number. So we're done. Can't be done. This is not a solution because it does not satisfy the equation. No solution. All right, number 31. Okay, same thing. Not too difficult of a problem. I mean, we have a radical on one side and a radical on the other side. They're already isolated for you, so really, you're just gonna choose a radical to eliminate. So I'm gonna raise this side to the third power because I have an index of 3. But if I raise one side to the third power, I must also raise this side to the third power. Okay? Now, when you raise a cube root to the third power, you're left over with the radicand. When you raise a third root to the third power, you're left over with the radicand. So there we go. Look at that. Now we're ready to solve this. Alright? So here we go. Bring the x over, make it a negative x. Bring the negative 4 over, make it a positive 4. And we're left with 2x equals 14. Divide both sides by 2, and x equals 7. So there we go. Alright, now, let's check our answer. Even though we know it's right, let's check it. Let's practice this. Okay, so we have the cube root of 3 times 7, and we have a 7 right here. Alright, now, 3 times 7 is 21, and 21 minus 4 is 17. So I have the cube root of 17 equals, I have a 7 right here. 7 plus 10 is 17. So I have the cube root of 17 equals the cube root of 17. And that totally checks. Alright. Moving on to number 33. Alright, now I have a radical equation. Obviously I have 2 radicals in this equation. So I would recommend moving one of the radicals to the other side. We have to isolate this radical or this radical. I would move the negative radical over so that it becomes positive. So we have the cubed root of 2x plus 15 equals, now we bring this over, equals the cube root of x. Alright. Now, I'm going to get rid of this radical because I just chose to. So it's a cubed root. I'm going to raise this side to the third power. If I raise one side to the third power, by the way, well, you raise the other side to the third power. Now, I did not put a 3 here because there's a 3 here. If there would have been a 5 here, I would still put a 3 here because you raised this side to the what power? Third. So what you did to one side, you must do to the other side. Now, why did I raise this side to the third power over here? Because I chose to eliminate this radical. You have to pick one of the radicals to get rid of, and I chose this side. Okay? Alright. When you cube a cube root, you're left with the radicand. When you cube a cube root, you're left with the radicand. And we're doing pretty well, guys. Bring the 2x over. Make it a negative 2x. There's a positive 1 here. So we're left with 15 equals negative x. Now, if 15 equals negative x, then negative 15 equals x. So that's my answer, negative 15. Now let's check it and make sure it works, okay? So I'll put a negative 15 here and a negative 15 here. Now, if you're thinking, oh wait, right away it fails, we have a negative radicand. Remember, when your index is odd, you're allowed to have a negative radicand. When it's even, you can't, okay? So 2 times negative 15, this whole thing here becomes negative 30. Negative 30 plus 15 is negative 15, so I have the cube root of negative 15 minus the cubed root of negative 15. Well, guys, you know you cannot subtract radicals or add radicals unless their indexes match, and they do, unless your radicands match, and they do. So we can subtract these two radicals, okay? Well, there's a 1 here and a 1 here. It's like 1 minus 1 is 0. I mean, you have the cube root of negative 15 minus the cube root of negative 15. It's just 0. They cancel out. So 0 equals 0 does check. It does check. Alright, number 35. Okay, we have a radical equation. We want to isolate the radical. Well, we only have one radical, and it's isolated already. So next we want to eliminate. There's a 2 here, even though you can't see it. So we have to raise one side of the second power. We must raise the other side of the second power also, okay? So when I square a square root, I'm left with the inside, which is 2x, the radicand. When I square x minus 4, that means to write the parentheses twice. So here we go, take your x and multiply it through. X times x is x squared. X times negative 4, negative 4x. Now take your negative 4 and multiply it through. Negative 4 times x is negative 4x. Negative 4 times negative 4 is a positive 16. Now combine your two like terms, your two x terms, and you get x squared. You owe me 4, you owe me 4 more, so you owe me 8. Positive 16. Alright, there we go. Now, obviously we're left over with a quadratic equation, and that kind of stinks. That's going to be a lot of work, okay? But it is what it is. So hopefully you remember how to solve a quadratic equation. You want to get one side equal to 0, so bring your 2x over and make it a negative 2x, okay? So we're left with 0 equals x squared minus 10x plus 16. So this is my A, my 1 right here. This is my B, and this is my C. Remember this wonderful formula. And here we go. So negative B is a negative 10. So negative 10 is positive 10. And then b squared, we're going to square negative 10 and get 100. And then negative 4. AC, 1 times 16. All over 2a. A is 1, so 2. Now next, we simplify under our radical. We have a negative 4 times 16. That's a negative 64. So negative 64. So now we have 10 plus minus the square root of 100 minus 64 is 36. All over 2. So now we have 10 plus minus 6 all over 2 because the square root of 36 is 6. Now because we have a plus minus, we have two different fractions. We have 10 plus 6 all over 2, and we have 10 minus 6 all over 2. Alright? So this would give us 16 over 2 is 8. There's one answer. And then 10 minus 6 is 4. 4 over 2 is 2. So my two answers are 8 and 2. However, when you look up here, they only say 8's an answer. But we're saying 8 and 2. Well, here's why. What have I told you guys? You have to always check your answer is correct. So when you check 2, it's not going to work. Watch. Put a 2 in for x right here. You have 2 times 2. Put a 2 in for x right here. Alright? 2 times 2 is 4. The square root of 4 is 2. 2 minus 4 is negative 2. So you get out 2 equals negative 2. And that's not true. Now, if you check 8, you'll get out a true statement, okay? Put an 8 right here for x. 2 times 8 is 16, so the square root of 16 is 4. Put an 8 right here. 8 minus 4 is 4. 4 equals 4. Alright? Moving on to number 36 or 37. Alright, now, same thing again. We're probably going to have to end up using the quadratic equation again, which is fine, okay? Here we go. We have a radical equation. We see that right away. Here's my radical. Here's my x under the radical. So step 1 is to isolate the radical. It's already isolated. Step 2 is to eliminate the radical. So because there's a 2 here, I'm going to raise this entire side to the second power. So I must raise this side to the second power. When you square a square root, you're left with the radicand. And when you square x plus 2, that's really like x plus 2 times x plus 2. Take your x and multiply it through. X times x is x squared. X times 2 is positive 2x. Now take your 2 and multiply it through. 2 times x is 2x. And 2 times 2 is positive 4. Add your like terms right here, and you're left with x squared plus 4x plus 4. Alright? Now right away you notice you have a quadratic equation. So you know you want to get one side equal to 0, so bring your 8x over and make it negative 8x. Bring your 1 over and make it a negative 1. So we're left with 0 equals x squared negative 4x positive 3. So a equals 1, b equals negative 4, and c equals 3. Alright? And let's see what happens. I'm getting a little tired of copying this over and over, so let me copy it in case we need it again later. Alright, now, negative b, and b is negative 4. So we have negative 4, that's a positive 4, plus minus the square root of b squared. Square the 4, you get 16. Negative 4, ac, a times c, 1 times 3, 3. All over 2a, a is 1, 2 times 1. Now, we simplify under the radical. Negative 4 times 3 is a negative 12. So I have 16 negative 12. Well, 16 negative 12 is the square root of 4. Alright, all over 2. Well, the square root of 4 is 2. So I have 4 plus minus 2 all over 2, which is going to give me two different fractions. 4 plus 2 all over 2, and 4 minus 2 all over 2. Alright, 4 plus 2 is 6, 6 over 2 is 3. 4 minus 2 is 2, 2 over 2 is 1. So my two answers are 3 and 1. Now in this case, we're going to check both answers, and they're both going to work, okay? Put a 1 in for x. 8 times 1 is 8 plus 1 is 9. Put a 1 right here. 1 plus 2 is 3. The square root of 9 is 3. 3 equals 3. Now let's check 3. Put a 3 in for x right here. 8 times 3 is 24 plus 1 is 25. Put a 3 right here for x. 3 plus 2 is 5. The square root of 25 is 5. 5 equals 5. Alright? And lastly, 29. Here we go. Okay, we've already got a radical isolated. Now if you wanted to, you could bring this 3 over and make it a negative 3 and isolate this radical, but I would not suggest that. You've already got a radical isolated, so let's just leave it like it is, okay? This radical is totally isolated, so let's eliminate this radical. Let's just get rid of this so we can make it a little bigger, alright? Doesn't really matter if you guys see the answer anyways. Alright, now, this is a square root, so we're going to raise this left side of the second power. But I must raise this side of the second power also. Now, when you square a square root, you get what's on the inside. Over here, I square 3 minus the square root of 2t. This is going to be pretty tough, so pay attention, okay? Alright, take your 3 and multiply it through. 3 times 3 is 9. And 3 times negative square root of 2t would be negative 3 square root of 2t. Now take your negative square root of 2t and multiply it through, okay? Negative square root of 2t times 3 is negative 3 square root of 2t. Now a negative square root of 2t times a negative square root of 2t. This times this. Well, look, negative times a negative is positive. And anytime you have the exact same square roots being multiplied, you end up with a radicand. The square root of 2t we have square root of 2t, square root of 2t, so we combine the outside numbers, negative 3 and negative 3, negative 6, square root of 2t plus 2t. Alright, so all of this will go up here. There we go. When we squared this, we got this. Alright, now let's continue on. Do you notice that we have another square root? Sure, you notice that. So we have to isolate this and get it all by itself, okay? So first of all, bring the 9 over and make it a negative 9. Bring the 2t over and make it a negative 2t. Well, thankfully those cancel, makes it a little easier. 3 minus 9 is negative 6. So negative 6 equals negative 6 square root of 2t. Alright. Now, the radical is still not isolated. So now we gotta divide both sides by a negative 6. And when we do, we'll get 1 equals square root of 2t. Alright? Now we finally have the radical isolated. It's a square root, so we're going to raise to the second power. But if you raise one side to the second power, you must raise the other side of the second power also. So 1 times 1 is 1. And when you square a square root, you get what's on the inside, the radicand. Now divide both sides by 2. And 1/2 equals t. Wow, that was a lot of work. But we got it right at least. Okay, now let's check our answer. 2 times 1/2. Well, 2 times 1/2 is 1. No, yeah, 1. And 1 plus 3 is 4. So I have the square root of 4, which is 2. Now let's come over here and put a 1/2 right here. 2 times 1/2 is 1. And the square root of 1 is 1. So 3 minus 1 is 2. 2 checks. 2 equals 2. Guys, these problems can be decently challenging, so I hope you're working hard on these, and I hope you're understanding what you're doing. I hope this homework help video was a help to you. If you have any questions at all, please don't hesitate to call or